Sure.
No problem. Okay. Now, so we are talking about carbon and its compound, and this branch of chemistry, when you study about carbon and compound, is called as organic chemistry. All right. So, to start off with, I'll talk about carbon first. Let's see what information we have about carbon. So, what is the symbol of carbon? C. Yes, carbon is represented by C. Now, tell me, in carbon, what is the atomic number of carbon? What is the atomic number? 6. Very good. What is the mass number? Very good. Atomic number is 6, mass number is 12. You all know atomic number is written below, mass number is written above. Okay. Next. Also tell me how will we write the electronic configuration of carbon? Very good. You will write K shell, L shell. K means shell number 1. Very good. So 2 and 4. So what is the last shell, valence shell? Everyone tell me. Yes, the valence shell is L shell. L is the valence shell. Valence shell, the last shell. The last shell is also known as aka valence shell. Understood everyone? Now tell me students that how many electrons are present in the valence shell. So can we say valence electron is, what do you mean by valence electron? The electrons present in the last shell. So that is also 4. Okay, let's talk about what more information we have about carbon. So, students, tell me carbon is a metal or a non-metal? Very good. Yes, carbon is a non-metal. Okay, carbon is a non-metal. Okay, next you have to talk about, I will tell you a very interesting story. Okay, so this story is about vital force theory. What it is? Vital force theory. This will not come in the exam, but this is important for you to understand the evolution, how study of carbon has all started. You need to know first why are you studying, how it all began. Right? A bit of history I'm going to tell you. You will not find this in NCRT books. You will not find this in the exam also. But you need to know how it all began. So I'll write it here, not in syllabus, but important for you to understand, not in syllabus. Vital force theory. So understand what was, Aditya, keep your camera on. So what is vital force theory? Earlier, people and scientists were believing the organic compounds, means carbon compounds, cannot be produced in lab, cannot be produced by humans because it requires a superpower, right? It requires a something like creation of God. It is not possible for humans to create organic compound. That is vital force theory. Is it clear? So vital force theory is, vital force means superpower, creation of God. Okay. So it means organic compounds. It means carbon and its compounds. Organic compounds cannot be cannot be prepared artificially as it requires as it requires vital force. What do you mean by vital force? God's creation. God's creation. It means scientists were believing in superpowers. Irony. Okay, science never believes in that, but earlier it was. Believed something like that. Now, online, everyone understood this. All of you unmute your mic and tell me.
Yes, sir.
Yes, sir.
Yes, sir.
So,
Yes, sir. Yes, sir.
Yes.
perfect. Later on, what happened? There was one scientist. Okay, his name was Berzelius. Okay, he actually concreted this theory. He actually said this theory is true. You need a God's creation. All right. Huh? Keur, keur. So, right, understand Berzelius was the name of the scientist. You don't have to know the name either. But later on, one scientist came. His name was Wöhler. Is it Whohler or Woh? I think it's Whohler. Wöhler. Huh. Wöhler. Yes. So Wöhler was the scientist. Now what you're learning is Wöhler synthesis. He was doing something and he did something else. Means he was preparing something in the lab, but it made something else. Accident happened, and that accident gave the first ever organic compound. Then people were like, oh, so we don't need a superpower. Okay. And that led to millions of compounds formed. And today, your medicine, what you are taking, is nothing but organic compounds only. The drugs which are made, right? For you to make you feel better, supplements, and so many things. Your hormones, your enzymes, your entire body is made up of carbon. It's carbon compound. Is this clear, everyone? Majority of the element which you have in your body is carbon. Understood? Your body, all living organism, majority is made up of carbon. Yes, yes. Remember this. So, Wöhler synthesis may now I will tell you what he was doing and what it happened. So he was doing a very simple reaction. You all have studied in 10th grade. You know what he was doing? He was doing double displacement reaction in the lab. You all know double displacement? Tell me, students, what happens in double displacement? Tell me, how will you explain? Just say anything. Just
Neutral exchange of ions.
exchange of ions, right? Two active metals in their salts, they exchange their salts, right? Exactly. So write it down. I will tell you a reaction. Actually, I will not do this reaction. You will do it. What Wöhler is doing. Yes. What happened? Why you people are scared? So write it down. He was taking ammonium cyanide. What happened? Why you are so shocked? What is the formula of ammonium? NH4, simple. Cyanide is CNO. So, say ammonium cyanide. He was preparing ammonium cyanide. Write it down. So he was preparing ammonium cyanide by using ammonium chloride. What he was using? Ammonium chloride and potassium cyanide. Remember, cyanide is, I'll write it here. CYNA. Cyanate is CNO. How do you write cyanate? And its valency is -1. That's it. So write it down. Cyanate spelling I wrote wrong. CYANATE. All of you take a note. Cyanate. Just like so many ions, take down cyanate. You know what cyanide is? What is cyanide, Saket? Cn minus. Right? Cyanide is Cn minus. Cyanate is CnO. Got it? Both have -1 valency. Online is everyone clear? So tell me you'll do double displacement. What do you get? You will get double displacement, right? Wait, I'll ask someone from online. Archit, you tell the answer. What do you get in double displacement?
We get Salt.
Obviously, you will get a salt. Which salt will you get?
Um,
You don't know how to
N.
write? See,
Um,
plus minus. Exchange them. That's double displacement. Simple.
right.
So, Archie,
Right.
can you tell the answer?
Or is it NH4CNO plus
Very
KCl?
good. NH4CNO plus what? KCl, right? What do you
KCl.
get? KCl, potassium chloride. Now he was actually preparing this, but mistake happened. And now I'll tell you how mistake happened. So this reaction was heated, okay, but unfortunately or fortunately, the bowler he was doing this in lab, okay. What happened was he was actually supposed to do this, okay, but he forgot to turn off the heat. So prolonged heating happened. He heated a bit more. You got it? Something like he's cooking something and he overcooked it. So prolonged heating happened. So prolonged heating, due to prolonged heating, this NH4CNO rearranged. What happened? This NH4CNO rearranged. You know what it rearranged into? Arey wah. How you people know this? It's there in NCRT. Oh, okay. Then it's in syllabus. It's given in NCRT, that means in syllabus. So it formed, oh, they just wrote urea as the first organic compound, right? So now you know everything, right? So it formed urea, guys. Okay, now how urea came? What's the formula of urea? Let me show you. Urea is like this, NH2, CO, NH2. Now tell me, all of you see here, how many nitrogen is here in ammonium cyanide? Wait, online students, turn off your mic, turn on your mic and tell me how many nitrogen is here? Total
Two.
how many
Two.
nitrogen? Two. How many nitrogen here?
Two.
How many oxygen here?
One.
How many
One.
One.
oxygen is here?
One.
One.
How many carbon is there?
Four.
Four.
Sorry, say one. One. One.
One, here one.
One.
And how many hydrogen is there?
Four.
And how many is there?
Four.
Four, no. No, no need to confuse. So do you see, chemically they have same thing, right? Only the structure is different. It is ammonium cyanide and this became the first formation of first organic compound. And this was just the beginning. Today we know so many of them. And that gave the birth of study of organic chemistry. Okay? Online, does everyone understood? Please tell me.
Yes, sir.
All right, that's great to know. So it was an discovery by an accident. Okay. So we use a term when something happens by an accident. It's serendipity, right? If you want, you can write it down. Serendipity. Ditity. Write it down. Accident, invention by an accident. Invention or discovery.
So DIPITY, right?
Dipity. Oh, D. It's pity. Now it's fine. Understood, no? Write it down, guys. It's pity in the end. Yes, that's right. So serendipity. Invention or discovery. Invention or discovery by an accident. Accidentally, unknowingly, means you have never thought of it, but it happened. Okay. And in organic chemistry, there are few more accidents, which I will tell you later. Yeah. So is everyone done? And now, so let's talk about carbon a bit more to understand. Okay. So what we discussed, carbon has how many valence electron? Yeah, 2 comma 4. So 4 was the number of valence electrons. Hey, why this is happening? Just be at one place. Don't keep moving here and there. Okay. This is not a Mario Kart. Right. Now, so understand 2 comma 4, 4 valence electron. Now understand due to this 4 valence electron, it gives carbon a lot of superpowers. I will tell you what are those. So important features of carbon. Question arises, why do you know there are unlimited number of carbon compounds? But the question arises, why do carbon has so many compounds? Okay, why do carbon has many compounds? This is a very common question which they will ask in the exam. What is the reason? So before I talk about this, I'll tell you another story. So what happened in the school, there was a teacher who gave everyone a task, and the task was to write the name of the relatives in their family. Okay? So everyone were busy in writing the relative names. Some came up with 10 names, 20 names, 30 names, 100 names. Means relative means all relative, which are, from your father's side, from your mother's side, all a full family tree. But there was one student, he kept on writing and writing. 8, 9 periods he wrote, but still he could not finish. That student was carbon. Understood? Now the question is why this carbon has so many relatives? I mean, why it has so many compounds? So you need to understand that the reason is because of two superpowers. Carbon has two superpowers, and it is all because of having 4 valence electrons. Now understand, the two main reasons are, number one, we call it as catenation. What do we call? And the second is tetravalency. Tetra Tetravalency means 4 valency or 4 valence electron. Can you see 4 means tetra, right? So understand, first of all, carbon have tetravalency. It means it can make 4 bonds. It can make, due to tetravalency, it can make, now again started, you will hurt yourself, you will damage the thing. Let it be, later on you will take it. No, just be there as it is. And don't rub it up over another. Now, so tetravalency means it can make 4 bonds. It can make 4 bonds. Is it clear? So you can see each carbon can make 4 bonds due to tetravalency. And catenation means self-linking property. What is it? Self-linking property. First of all, each carbon can make 4 bonds, and self-linking means carbon can join with another carbon. So see, it keeps on growing. Each carbon has 4 carbon and it will keep on going, Can you see that? So much. So that is how it keeps growing into a large, long, different compounds. Is everyone clear about it? Please tell me. Did you all understood why carbon has so many compounds?
Yes, sir.
Yes, sir.
Okay. Now remember one more thing. Carbon cannot form ionic compounds. Why? Explain. So understand, you need to know one more thing. Carbon cannot form ionic compounds. What is the reason? Again, the same reason, four bonds, four electrons. See, carbon has 2, 4 electrons in the valence shell. So understand, students, in ionic compounds, you know what happens? We have studied about it, right? One completely donates, one completely accepts. But the problem is carbon cannot accept neither donate. So write it down. Due to 4 electrons in valence shell, due to 4 electrons in the valence shell, carbon cannot cannot lose or gain electrons to form ionic bond, to form ionic compound. Now the question arises why? Why cannot carbon lose 4 or gain 4 electrons? See, if it loses 4, it will become a noble gas. If it gains 4, it still become a noble gas. But it can't do anything. Why? Why? Because gaining 4 electron takes up a lot of energy, which is practically not possible. Similarly, losing 4 electron also takes up a lot of energy, which is practically not possible. So write down the reason, students, why it cannot gain or lose 4 electrons. So reason is very simple. Gaining or losing of 4 electrons requires the large amount of energy, large amount of energy. Both gain and lose requires large amount of energy, which is practically not possible. So that is why carbon cannot form ionic compounds. Online, is everyone clear?
Yes, sir.
Yes, sir.
Yes, sir.
Now the question arises, what option do carbon has? Sharing. Sharing is caring, covalent bond, right? So that is why carbon, so you need to write carbon can only share the share its electrons. Share its electrons. Okay? That is, it forms. So what do you mean by sharing which bond? Yes, it forms covalent bond. See, when it is between metal non-metal, it's ionic. When it's between non-metals, it's called covalent. And when it's between metals, it's called metallic. Clear? Simple? Okay. Now I'll give you some examples, students. Let's take some examples. Okay. So example may first we will talk about first compound CH4. Do you know what is the name of this compound is? Methane. Another example I'll give you is CO2. I think you all know the name of CO2. Carbon dioxide. So now students, I'll show you a demonstration by Lewis dot structure. So example
Sir,
by
what dot structure?
Lewis dot structure. Lewis dot structure. Okay, Saket, you got it? So the rule says identify the central atom. So who is the central atom? The one which is in less in number. See, carbon is how many here? Hydrogen is how many? So who is less in number? So carbon is central, put center. The remaining hydrogen will be written on peripheral. Is it clear? Left, right, up, down. Is everyone getting it? Now, the rule says Lewis dot structure that indicate the valence electron by a dot. So carbon has how many valence electrons? So represented by a dot. And hydrogen has how many? Only one. Now see, hydrogen needs one electron, carbon needs four electrons. So they will share with each other. See here, sharing is caring. In that way, hydrogen get 2, carbon gets 8. And all became noble gas configuration. Hydrogen became like helium, carbon became like neon. Okay? Is everyone clear? This is how. So tell me how many electrons are they sharing? One each. So when two electrons comes together, they form a single bond. When two electrons come together, they form single bond. So how many bond will be here? So there will be, see, two electrons making one bond. Here two electron made one bond. This is the structure. I hope you all understood how to do it. Online, did everyone got it? Everyone? Kindly confirm.
Yes, sir.
Perfect. So in that way, hydrogen atom acquired helium configuration, that is a noble gas, right? And carbon atom acquired neon, right? After carbon, the next noble gas is neon 10, right? Neon, which is also a noble gas. Now they are happy, they are stable. That is why bond formation happens, right? To acquire stability, noble gas configuration. Okay? Indra, you got it? Good. Now I will tell you about CO2. So students, let's talk about CO2. So CO2, how many carbon is there? One. How many oxygen is there? Who will be the central atom? So carbon
So
is
one
less.
doubt.
Yes.
So you drew two diagrams for methane over there. One is with the dots and one is without.
This is Lewis dot structure, and this is finally showing bonded. This is the
So
original
does
structure.
that
This is
structure
Lewis
have
dot.
any name?
This is regular structure. In chemistry, all the
Regular.
structures are like this. This is just structure. This is Lewis dot structure. Okay, understood now? This led to this. Got it, Saket? Now, tell me how many valence electron? Four, right? So draw one, two, three, four. Oxygen has how many valence electrons? Six. So one, two, three, four, five, six. How many oxygen that oxygen will have? That also will have six. Can you all see this? Six I have drawn, right? Now, oxygen needs two, carbon needs four. So see, they will also fulfill their wish. So how it will work? Oxygen will share its two, carbon will share two from each oxygen, so total of four. So because two electrons are shared, so double bond will come. Every two electron makes one bond. So there are four electrons. So make how many bonds? Double bond. This is the structure. This led to this. Is this clear? Understood everyone? Online, did everyone got it?
Yes, sir.
Yes, sir.
Okay. If anyone is not getting it, tell me now. This is the time. This chapter will become very complicated later on. So your basics needs to be clear. That is why I am telling you like full detail. Okay? Understood? Hmm? Okay. Next. Now you need to learn something called as covalency. Write down what you will be learning now. Yes. The number of, what is covalency? The number of electrons shared by each atom. The number of electrons shared by each atom is covalency. Did you all understand the meaning of covalency? So Saket, you tell me how many in methane, what is the covalency of carbon is? How many electron is it
Nearly
sharing?
4.
Yes, very good. So the covalency of carbon is 4. Now what is the covalency of each hydrogen?
1.
Yes, very good. So the covalency of each hydrogen is 1. Similarly, Manvi, you tell what is the covalency of oxygen, each oxygen?
Two.
Yes, very good, 2. Now, Neha, you tell me what is the covalency of this carbon in CO2?
Four.
Very good, 4. So you understood the meaning of covalency now? Simple. Remember, covalency is each atom. Many students, what they do mistake, they count it to 2 and then they say 4. It's each atom. Focus here. It can never be clubbed. It's each atom, per atom. Got it, no? Now, now we will study compounds of carbon. What are we studying, guys? Yes. We call it as hydrocarbons. What do we call them? Compounds of hydrogen and carbon. See, whenever, for every Batman there is a Robin. For every carbon there is a hydrogen. Keep that in mind. So when we say compounds of carbon, by default hydrogen will be coming up. So we call them hydrocarbons. What do we call them? Hydrocarbon. Write down. Hydro means hydrogen, carbon is carbon. So compounds of carbon, and even if you don't write carbon and hydrogen, it by default hydrogen is there. You know, hydrogen comes by default with that. So you can say hydrogen is that green chili or coriander leaf which comes when you buy vegetables, right? You got it, no? It comes for free along with that carbon. Understood now? So remember, hydrocarbons are mainly categorized in 3 categories. Can anyone tell me what are those 3 categories are? Yes, very good. So there are 3 categories of hydrocarbons. Okay, students. So we have alkene, and we have alkene, and alkyne. Yes, alkene, and alkyne. Clear? Now, so in alkane, remember how we identify, how will you distinguish between them? So remember, alkenes have carbon-carbon single bond. What they have? Carbon-carbon single bond. Got it? Alkenes have at least one minimum carbon-carbon double bond. What they have? At least one carbon-carbon double bond. And how do you identify alkyne? Yes, carbon-carbon triple bond. I hope it's clear. Everyone write it down. Now remember, the one which has a single bond is called saturated hydrocarbon. So what it is also called as? Saturated hydrocarbon means simplest hydrocarbon. And the one which has multiple bonds, both of them, what do we call them? Because they have multiple bonds, what they have? Double and triple, right? Because they have multiple bonds between two carbon atoms, what do we call them? Unsaturated hydrocarbons. Yes, we call them unsaturated hydrocarbon. Write it down.
So they're called unsaturated because these double and triple bonds can be broken to accept more hydrogen, right?
Yes, these two can be brought down to this. But when they are brought down to this, they become saturated. Okay?
That's the reason they're called. Okay.
Yes, you can't further, break it. Saturated is the last limit. Okay? Clear, no? Now understand here what you need to know. They are identified by some special formulas. So I will write it here. Wait. So write it down here. Alkane, alkene, and alkyne. So they are identified by some special formulas. All right. Alkane, alkene, alkyne. So alkane is written as CnH2n plus 2, and alkene is just CnH2n, and alkyne is CnH2n minus 2. Very good. Very good. Now, what does it mean? What does it say? Let me tell you. It says if carbon number, whatever the number of carbon is, double the number of hydrogen is, and on top of that plus 2. So tell me, if carbon is 1, what will be the hydrogen then?
4.
1 ka double is 2
6.
and plus 2. Understand? Carbon is 1, so N becomes 1. So carbon is 1, so what is the double of 1? 2 and plus 2. So 2 plus 2? Yes. Similarly, here it says whatever the number of carbon is, just the double. So if carbon is 1, what is the hydrogen then? Hydrogen is just 2. And it says double and then minus. So understand, however, carbon can form how many bonds? Carbon has how many bonds? 4. But how many hydrogens there? So it does not exist. Carbon has 4 bonds, but how many? So it means it does not exist. You know the reason why it does not exist? Yes. So similarly, what will happen here? Carbon is 1. What will the hydrogen? Double and minus 2. So it will become 0. So that also does not exist. Now let's consider as carbon has 2. So what will be the hydrogen? Online, everyone tell now. How many hydrogen will be there?
6.
Very good. You know, double of 2 is 4 plus 2 and just double. So it will become C2. Now you might wonder, sir, there are 2 carbon, it should have 8 bonds, but it exists. I will tell you how later on. Remember, this exists. Also, why it does not exist? Because carbon should have a double bond, but here only one carbon is there. So remember, it does not exist. Does not exist. The reason is their requirement is carbon carbon should have a double bond. So to have a double bond, we minimum require two carbon. Here only one carbon, and same reason here. Okay, so here it does not exist. The reason is we need two carbon at least. At least two carbons needed for triple bond between them. Understood? No, no, we only need two. Same reason here you can copy. But C2H4 may requirement is fulfilled, right? You all got it? There are two carbons, so it can have double bond between them. Same thing here. There also, what will be the C2 then? How much H? Double minus 2. So 4 minus 2. So C2H2. Online, is everyone clear now?
Yes, sir.
Hmm. So same reason you can put it here. And in place of triple, you put double. I think you all got it, right? Understood, everyone? Now we will talk about students is if C3 is there, then how much will be the
H8,
H8? Very good. And what about this?
H6, C3H6,
C3, H6. And in that case,
C3H4.
absolutely. Double then minus 2, right? Now let's do some questions, students. Now in questions you have, I'll give you a formula. You will identify is it alkane, alkene or alkyne? Yes. So question is identify the following compound. Identify the following compound as alkene, alkyne or alkane. So I will be giving you formula, you will be identifying them. Okay. So first, understood everyone? What is the question?
Yes, sir.
All of you solve these questions. Is everyone done? Online, what's the update? Is everyone done?
Yes, sir.
Yeah, yes, sir.
Perfect. Now, so everyone tell me what is the first one? Yes, this is alkane because it's fitting in that formula double plus two, right? What is this? It's just a double, right? So when it's just double, it's alkene. And if you see it's double and then less, two less. So we call them alkyne. Understood now, everyone? Now, in this case, it's double. So it is alkane. What about this? Yes, it is alkene. What happened to online students? Be louder. Oh yeah, it's double. No, so alkene. It's fine. Online, everyone, tell me why everyone's quiet. This is alkene. What is the fifth one?
Alkene.
Good. Alkane. I want everyone to participate last.
Sir, alkene.
Alkene. After that,
Alkene.
Alkyne.
double minus two. So
Alkyne.
we call it as
Alkyne.
alkyne. And last one,
Alkyne.
Alkyne.
yes,
Alkyne.
again it's alkyne. Good. Now, because you have already understood about the types of hydrocarbons, the compounds of carbon and hydrogen, now we need to learn because there are so many compounds, we need to learn what would be their names. Understood? We need to learn their names, IUPAC name. Okay, so now we need to learn naming of organic compounds. Give the headline naming of organic compounds. Naming of organic compounds, students. And one more thing. In the naming of organic compounds, we will study IUPAC name. So full form of IUPAC is you need to know first. So the full form of IUPAC is International Union of Pure and Applied Chemistry. You have to remember this full form. International Union of Pure and Applied Chemistry, IUPAC. Question arises, why do we need to learn this? So say IUPAC have set up a rule, a standard rule which is followed all over the globe. So if I say some name and if Aryan from Venezuela and Indranil from Brazil will also the same name according to the rule. It's a standard rule name followed everywhere. Because why this is needed? So no, it should not create a confusion. See, if we look it in our India, right? Just a onion has so many names. In Hindi, we call it as pyaz, right? Kanda in Marathi, right? In Maharashtra, and I think I'm very sure there would be many names in other regions, right? Is everyone clear? Like egg. Egg is anda in Hindi. Then you say dim or dimmer in Bengali. Then if you come to Karnataka, it's mutte, right? So yeah, there's a different names, right? Getting it now, everyone? So
Yes, sir.
imagine in India, one onion can have like almost around like 30, 40, 50 names. Imagine the globe, what would be the number of names for just an onion. So to not create a confusion, we have to learn a standard naming protocol, a procedure given by IUPAC by following some guidelines and rules. So the name will remain the same everywhere and it will not create a confusion. Online, is everyone clear? Why do we need this name?
Yes, sir.
Yes, sir.
Now, remember, this name has three parts, three main parts it has. Okay, this IUPAC name contains three parts. Okay, One first part is the main part. It's called word root. Now I'll take one example of someone's name. Okay, I'll take the example of my name only. So guys, my name is, if I have to write my name, okay, Mr. Vikram Singh. So this is my name. Okay. So how do you know me? By which name? Mr. or Singh or Vikram? Vikram. So you mainly know me by Vikram, right? So that is the major name, that's word root. Mr. is written before the word root, before the main name, it's called prefix. And this is written after the word root, after the main name, it's called suffix. So similarly, like my name and your name, everyone's name, IUPAC also has these three parts: prefix, main name, the word root, and suffix. Is everyone clear? So what you write before word root, it's called prefix, and what you write after word root is called suffix. Understood, everyone? And remember, when you merge these three, this gives you IUPAC name, complete name. Online, open your mic. Tell me, did you all get it?
Yes, sir.
Yes, sir.
Yes.
Yes.
Great. Okay. So now, also students, keep a note that this Thursday you have off. There's nothing this coming Thursday. Oh, math exam is there. Okay. But next Thursday, you are supposed to have off. If math exam is there, I was not knowing about it. Remember, you will have a chemistry important discussion. Okay, chemistry recall you have. Neha ma'am will be taking it. Okay, Thursday. Not this. Next.
Sir, will it be
Online. It will always be online for now. Okay. She may come in the month of January, February during her exam revision time. Then offline you can expect. Right now, it will be online. Okay, so guys, now we will talk about these three things one by one. So all of you give a headline. First, we need to learn about the word root. So first, let's talk about the word root. So word root, what is the word root? Word root is the number of carbon atoms in the long continuous in the longest continuous chain, which we call it as a principal chain. Guys, write it down. Longest continuous chain, what do we call it as? Principal chain. Okay, I think it's not principal, it's PLE, right? My bad. Okay.
Sir, in this case, chain
Yeah.
refers to all kinds of combinations, right? Rings as well, the branches as well.
Yeah, understand. You don't have to go that beyond. I'll tell you one by one. Okay, let's go slowly. For now, just remember, answer to your query and question is longest chain. Suppose if I give you a compound, there will be some branched, some long, because carbon can form join catenation, right? Carbon can join. So longest possible chain, whatever you can count, that becomes a word root. Don't worry, I'll give you an example. But important thing is you stress on this longest continuous chain. Okay, longest continuous. Yeah, who has a doubt? Now, so remember, if the longest continuous chain is 1, we use the name myth. If there is only one carbon in the chain, it's called myth. Don't say methane, just myth. And if there is 2 carbon, what do we call?
It.
It. And if there is 3 carbon, what do we call?
Pro.
Prop. Remember myth, it, prop. And if there is 4 carbon,
Bute.
bute, 5 carbon,
Pent.
pent, 6 carbon,
Hex.
7 carbon is,
Hept.
Hept.
and 8 is,
Oct.
and 9 is
Non.
non. And last 10 is deck. After that also you have, but you don't have to learn in 10th. It's undeck, dodeck, trideck, and so on. Okay, leave it. So guys, remember this. Longest continuous chain is myth, eighth, prob, depending on how many carbons are there. In your syllabus, you have to learn only till deck 10. Okay, take a note of this. Then I will introduce you what is the prefix. Okay, after word root, I will introduce you the prefix. Write down the word root, everyone. I will tell you later how to know, how to find. Later on, I will be telling you in the rules how to identify the longest continuous chain, the principal chain. Okay. So remember, should I tell you about the prefix now? Written online, everyone tell me.
Yes,
Yes,
sir.
sir.
Done.
Okay. So after word root, you need to learn about prefix. So remember, prefix is a, what is prefix? Prefix is a branch, okay, which is, it is a branch which is not a part of, which is not the part of principal chain. All of you write down. So technically prefix is something which is not included in the longest continuous chain, which is a branch. I hope it's clear. So now there are many examples. First is alkyl, the very common one. Alkyl group. Remember, they are represented by R. How they are represented by R. Alkyl groups, which is a prefix, which is not a part of the chain, are represented by R. Now remember, alkyl groups formula is CnH2n plus 1. Okay. In simple words, I can tell you from alkane, if you remove one hydrogen, it becomes alkyl. I hope it's clear. I'll give you example. So from methane, if you remove one hydrogen, what it will become? CH3, it's called methyl. And similarly, C2H5 is ethyl. Similarly, C3H7 is propyl. Propyl, butyl, and so on. Did you all understood what alkyl is? Online, tell me everyone.
Yes, sir.
Alright, sir.
Also remember C2H5 ethyl can also be written like this CH3CH2. It is C2H5 only. Similarly, propyl can be written as, propyl is written as CH3, CH2, CH2 and so on. Got it, no? It's C3H7 only. Hope it's clear to everyone. Good. So don't get confused in place of writing this if they write like this. Both are same. Got it? So this is alkyl. Second is you have to learn the halogen. We represent them by X. Second type of substituents. Students, remember one more thing. These prefixes are called as branch. Sometimes they are also known as substituents. What do we call them? Branch or substituents. Branch or substituents which are not the part of the principal main chain. Understood? So now I'll tell you halogen.
Sir,
Uh,
in principle, it's PAL. Yes, sir.
where you're telling?
Chemistry,
Acha,
sir.
that's okay. I was always having a confusion on that. No, it's fine. It's Ellie is correct, no? Saket is telling it's AL.
No, 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 sir. It's AL.
It's ALs.
It's AL. It's AL.
Now here half of the people are telling it's LE.
Sir,
You are
consider.
telling it's
It is
AL.
AL.
Consider, sir.
It
AL.
is
Ha,
AL.
AL then AL. Okay. Consider it as AL. So not just Silvi, it's ideal to write in a correct manner, no? Now, so it's AL. Okay. Now, so halogen may you have fluorine, chlorine, bromine. They will be, you'll find them attached as a branch. So when fluorine is there, we call them fluoro. Okay, chloro, bromo. It's written as iodo. Write it down. Chloro, fluoro, chloro, bromo, iodo. Everyone write on this.
So I didn't understand one thing.
Yeah, tell me.
How is the alkyl group a prefix? Because it constitutes an entire element as an entire compound as its own, right? For example, methyl is a separate compound. So how
Huh?
can it be
You
a
will see
prefix?
it when I'll give you the example and rules, then you will see it. For now, just take it
Okay,
down.
sir.
Yeah, you will see it. Also, before you write FLORO, you add U. FLUORO. Yeah. Now, third one I have to tell you, rectify fluoro, guys. Now, third is nitro. Nitro is nothing but just NO2. What it is? NO2. That's all, nitro. Okay? Understood, everyone? When NO2 is written, we call them nitro. Yes. And there is one more you need to know.
So, sir, nitro is a part of the branch, like NO2 is a
Hmm.
part of the branch.
Yes, it is a branch. It's not a part of the branch.
Okay.
It will be present as a branch. As a branch. Clear? Hmm. No, fourth is not there in syllabus. Only these three. Now I'll tell you about suffix. So, students, we will be talking about suffix now. All of you write it down. And I want you all, before I tell you suffix, please revise everything. Okay? All of you do this for 2-3 minutes of take your time and revise and keep your cameras on.
Sir, I have a question.
Yes.
I saw that I was doing questions from this chapter and I saw this compound HCHO. How would
Huh?
you name that?
Formaldehyde. Anyways, you'll be studying it later on. It's called formaldehyde, HCHO. Or it is also
Formaldehyde.
called as methanol. Yes. It's okay, I'll teach now. And anyways, hybridization you are supposed to learn in grade 11. It's you don't have to learn in grade 10. It's a part of. Anyways, I'll teach in grade 11. The first thing you'll study is this only in grade 11. So don't worry, in grade 11, these are orbitals. You can't learn like directly like that, okay? See, every shell, subshells, these are subshells. Yes, that's right. So those are a part of the subshells. It's okay. I'll leave it. In 11th, anyways, I'll teach you know, so don't worry. Yeah.
Sir,
Hmm.
I teacher taught us isomerism and polymerization also.
Polymerization you don't have to learn. Isomerism you have to learn. Isomerism is there. It's okay. I'll just start at carbon. No, you will get it soon. Everything. In the next class, we will do a lot of IUPAC first, and then I'll tell you isomerism also. That is the two things you'll be studying in next class. Now, revise it thoroughly, students. Is everyone done? Guys, I'll give you 1 more minute. Revise it. I'll tell you suffix after that. Hmm? Okay. So let's talk about this suffix, students. So we will talk about the suffix. Suffix is something you write at the end of the IUPAC name. What it is? So students understand in suffix you need to know there are two type of suffix are there. One is called primary suffix. One is called primary suffix and another is called secondary suffix. So when you write the name, first you will write primary suffix and then last, then next. You will be writing secondary suffix. Question arises, what is primary suffix? See, secondary suffix we will do our discussion in the later. They represent something called as functional groups. Okay, like alcohol, then you have amines, then you have carboxylic acids, you have aldehydes, ketones. Okay, so remember we will talk about it later. I'll tell you a basics. They represent functional groups. What they represent? Functional groups, but primary suffix you need to know right now. So primary suffix is, it represents number of carbon-carbon bonds. Number of carbon-carbon bonds. So remember, if there is a carbon-carbon single bond in the entire structure, you will use the suffix ane, A-N-E, ane. Is it clear? If at least one carbon-carbon double bond you come across, if at least you will come across one carbon-carbon double bond, you will use the suffix "ene." And if you come across at least one triple bond, at least minimum, so you will use the word "ine." Y-N-E. I hope it's clear. Did you all understood the suffix? Online, everyone, kindly confirm. Did you all get
Yes, sir.
it?
Yes, sir.
Perfect. So note it down, and we will be continuing this IUPAC name, and we'll do isomerism in the next class. Okay. So if you finish this, you can leave the class. Bye, everyone.
Bye and thank you, sir.
Bye, sir.
Bye, sir. Thank you, sir.
Thank you, sir.
Thank you, sir.